Water at the higher level is collected in the forebay. It flows through the plant intake into a pipe called a penstock, which carries it down to a turbine water wheel at the lower water level. The water pressure increases as it flows down the penstock. It is this pressure and flow that drives the turbine that is connected to the generator. Inside the generator is the rotor that is spun by the turbine. Large electromagnets are attached to the rotor located within coils of copper wire called the stator. As the generator rotor spins the magnets, a flow of electrons is created in the coils of the stator. This produces electricity that can be stepped up in voltage through the station transformers and sent across transmission lines. The falling water, having served its purpose, exits the generating station to the tail race, where it rejoins the main stream of the river.
All right, I'm going to interrupt right here and put Don Ellis in the KRXK mobile unit on.
All right, thank you very much, Lee Savage. We do have a very, very serious problem here at the Teton Dam.
Hot, this is 056. Abandon attempt to retrieve Cat 2. Repeat, abandon attempt and evacuate the area immediately.
As I sit here and watch, All right, you see it caving. It's just coming apart.
At 11:57 a.m. on June 5th, 1976, the Teton Dam collapsed, flooding homes and farms in the upper Snake River Valley with 80 billion gallons of water. Here are recollections of how the people faced that disaster and rebuilt their lives.
And the water is monumental. Holy great. What can I say? People downstream better get out. People downstream better get out.
Report from an aircraft in the vicinity of Sugar City. The wall of water is approximately 5 to 6 miles wide and is moving buildings and everything out of its way. There are cattle in the front that don't have a chance, and suggests that all the people that are anywhere near the river at all to get out of the way.
Though the warnings came late, and it was difficult to convince many people the dam indeed had burst, the timing of the flood in the middle of the day prevented mass deaths, and most residents were evacuated to higher ground where they watched the eerie occurrence of houses and belongings floating away.
The operating principle of this wave power station is as simple as it is ingenious. An enclosed chamber has an opening beneath sea level, which allows water to flow from the sea to the chamber and back. The water level in the chamber rises and falls with the rhythm of the waves, and air is forced forwards and backwards through the turbine, connected to an upper opening in the chamber. As it is compressed and decompressed, the airflow has sufficient power to drive the Wells turbine.
There's a device being built currently right now. It'll be about 130 feet long, about 200 tons, 3 pieces, the spar, the float, the ballast at the bottom, and it's going to be deployed off the coast of Oregon at Reedsport in 2011. And we hope to follow that with 9 more for a grand total of 10, and then we'll measure and see how those operate and hopefully move on to a much bigger project with 100 or 200 or more of these devices.
How far off the coast?
Well, the first project is going to be about 2.5 miles, but they could be anywhere from almost immediately offshore to as far out as you want to go.
So how does something in the water capture, how is that converted to energy?
Well, the wave energy device that floats out there like a big buoy has a piece that stays relatively stationary with the ballast at the bottom with a part on top that's a float. And that float moves back and forth in relation. And so you can do classic electrical generation from a magnet and coil, or you could hook up a rack and pinion system where you turn a turbine. Anything that creates a spinning device or relative motion can create electricity.
Could it include wind power too?
Eventually, very much so. We foresee a day whenever we'll have large floating platforms off the Oregon coast with both wind and wave integrated in one large platform.